security workshop. You're looking at the HAL 2001 ipsec team. We are our original plan was to describe the ipsec gateway and setup that we have built for HAL, but we're almost finished with that. So this is going to be a talk about ipsec in general. We talk a bit about what we're doing, I think, and it's an introduction. If you have questions, we'll see if we have time for that. Okay. Oh, my name is Stefan Adens, Kurt Seifried, Philip Bueller. Seifried. Okay. Good. IP security. Let's go. What exactly is IP security? IP security is it's a framework for secure communication on the internet. What does that mean? Right now we are using TCP/IP, mostly version 4. TCP/IP is the protocol that you use to connect to other machines on the internet to exchange information. And TCP/IP is built on a has no security. It's a protocol that only provides a transport mechanism for other applications to do transactions, to talk to web servers, to send data. So when people thought that it was time to secure the foundation of the internet software, a committee was formed, and as a result, ipsec, or IP security was created. ipsec basically does two things. It has an authentication interface and a confidentiality, which basically means that okay, I'm going to skip to my next sheet first. I think that's more appropriate. ipsec is based on two important concepts: authentication and confidentiality. Authentication means that you can check.
No, who sent it? It's not a replay or whatever.
Yeah. Authentication provides data source authentication. So, is the web server I'm talking to really that web server? It provides data integrity, which means that no one can tamper with your traffic. It basically means that all your IP traffic is encoded, or a hash is calculated over the packet payload that will that both sides will check to see if nobody changed the inside of IP packets. And this is important because on a network like HAL, like we have here, you are sharing the network with many people, and we've seen many people running tools like dsniff, or tools to capture secure shell sessions or take over your logins or whatever, which is very easy to do with IP because it's an unprotected protocol that anyone on the wire can tamper with. Okay, I'm going to switch back and forth between these sheets. So, what basically happens with the authentication part of ipsec is it adds some extra information to all the IP packets that you send on the wire, and it calculates a hash value on the whole packet. So it signs it. It's like a checksum that can only be generated. It's a checksum that can only be generated by using the original data and secret key.
Yeah.
So that basically prevents people from changing your IP traffic. This gives you protection against replay or man-in-the-middle attacks. A replay attack is when you capture, for example, a login or any network transaction and replay it again. It's just send the packets back and forth between your machine and another machine. Man-in-the-middle attacks are
Interception.
yeah, it's an interception between two machines. You basically means that say I'm talking to a web server. Someone can sit in between those two connections and take over my session. Well, with ipsec using authentication, that's not possible because all my traffic is signed with my key, and you have to know that before you can break into a session. It's basically protection against packet alteration. Okay. So, what more is an IP security? Next to authentication is an encryption layer. Encryption is very important because it
It allows you to talk securely without being monitored.
yeah, it allows you to talk securely to other systems without being monitored. Other people cannot look in your IP traffic and see what you are doing. Okay, maybe it's better to this part. Here we see two packets. The first packet is a standard IP packet that is unprotected, but it's got a header and some information in it. The information is like a request to a web server or part of a download or anything basically. Now what happens with ipsec is that all the data inside the packet is encrypted, so nobody can look at it. Nobody can look inside the packet. And it also adds the same authentication header that the authentication part of ipsec has. So this basically secures you, gives you a totally secure internet connection.
Talk about transport tunnel mode. You don't gateway to settlement.
Yeah.
That's what.
Okay, so ipsec can run in two modes. You can set up a secure connection between two machines. For example, if your web server or mail server supports ipsec, then you can set up a secure connection and do everything encrypted. That's called transport mode. It's direct connection between two machines. What you also can do is tunnel mode, and that basically means that it's mostly used to connect to another network. So that's what we would use here at Hall. Are we? No. Yeah. In tunnel mode, you connect to a secure gateway, which is then connected to an unsecure network or an internal network. So you have host-to-host communication and all the routing to a bigger network, which can be the internet or can also be your internal network. It's all encrypted. Okay. Now, ipsec is very, it's just another IP protocol. So it will work on any TCP IP network. It will work on your Ethernet, it will work on your wireless network, it will work on your PVP connections to your ISP. It's just another protocol, just like TCP or IP or ICMP. So it will basically work on any infrastructure. ipsec is it's an extension of IP version 4, which means that your operating system has to support it, or you have to install an extra software package before ipsec can be enabled. ipsec is an important feature of IP version 6, which is now under heavy deployment already. Okay. So what else?
Maybe talk about the problems with the key exchange, like there's no DNSSEC or whatever yet.
Yeah.
So it's really freeze within organizations.
Okay, let's see how much time do we have. Okay, so what exactly what exactly can you do with it, or what are we using it for? Well, some interesting things. For example, there are a lot of insecure internet protocols at the moment, like POP3 or FTP, which send your passwords in plain text, or have no built-in security or strong encryption. So by using ipsec, you can make insecure protocols secure, because nobody can snoop on your POP session when you retrieve your email. Nobody can look at your passwords when you are FTPing. So this is a very important important point. ipsec is also very interested when you want to share information with other people and you don't want anybody else to see it. You need some very heavy equipment to decrypt an ipsec session, because it will use strong crypto that will take many years on normal hardware to decrypt. So you can basically build a secure infrastructure between you and your friends, or you and your company, or you and your home network. You could run Napster on it and nobody would see it, or could see it, or you can use it between mail servers and create an infrastructure where nobody can look at your mail. What we use it for is, for example, we can connect to our ipsec gateways at home and make a secure connection to our homes, which is great because I don't want anyone here to see what I'm doing. Even if I use secure shell, it's still it's really a bit dangerous, because I can't retrieve my email from home, or can't send mail to my home's mail server. So when I built a VPN, a private network between my machine and my machine at home or at work, I built a secure channel in which you can do your work. Yeah.
And say it's transparent, the applications.
Yeah. Is it about? Okay. So, and this works great because ipsec is totally transparent. Your IP stack will encrypt and decrypt all of the traffic going in and out to the remote host. And the applications will not notice this, so you can run all your favorite applications over it.
Maybe tell them my open relay mail server and you can only talk to it with ipsec. You know, at home I have a mail server that's an open relay to the internet, but you have to talk ipsec to it, so you have to have a shared secret.
Okay.
That's how I do my email, for example.
Yeah. Okay. An interesting application is Suppose you have a mail server at home or at work, and you don't want, and you have many people on the road, like in different countries or different places or whatever, and you don't want to open your mail server as an open relay. And you can use ipsec with authentication to give only certain people access to your server. You can hand out certificates or hand out keys, and that will result in you know who is connecting to your server because you handed out the keys, and it's secure. So for mail servers, that's very interesting because you don't have to be an open relay. But instead, you can just tell people use ipsec with these keys. People will be able to use your server. Okay. ipsec is pretty complicated, but especially if you use one of the open source or closed source Unix variants, it can be very difficult to configure, but things are getting a lot better now. Especially on the Windows side, where most clients probably will reside. Current status of ipsec is looking very good. For BSD and Linux, there's the Kame project, or Kame. These URLs you can find more info about that. Kame is basically a research project done by I think a Japanese institution, and it was donated to FreeBSD and OpenBSD, NetBSD, and macOS 10, and they are using it to enable ipsec in those operating systems. There's a lot of good information on ipsec on their website. For Linux, there is I don't think ipsec is a standard part of Linux.
Some vendors, SUSE, Connectiva, several do actually.
Okay, some distributions do have ipsec built in, but you can always download the latest ipsec modules from freeswan.org, which is a popular ipsec implementation for Linux. OpenBSD is probably has the most stable and sophisticated implementation at the moment. So if you're really interested in building things like secure gateways or
hardware crypto acceleration.
Or use hardware crypto acceleration, then you're probably best off with OpenBSD. The manual pages on those operating systems also give a lot of info, so just type using a Provost ipsec to see what's available. On the Windows side, there's good news. It's built. ipsec is now built into Windows 2000. It can be very difficult to configure sometimes, but it works. It's actually a pretty stable implementation. Most people prefer to use something like PGPnet, which is a freeware. Now there is a free version, but it's a commercial package. But it's great software. We can. We don't have a laptop here with Windows now, but if you're interested, we can demo that in the FHQ tent or the OpenBSD tent.
Maybe take questions. Oh, more info.
Okay. Yeah, we've tried to put some key features and information about ipsec in these 25 minutes, but it's very difficult to give a really complete overview of ipsec in such a short time. So if you have if you are interested in ipsec on a technical level, you should probably start reading the RFCs, which can be found on the internet. Just Google them. We have a lot of people in the OpenBSD tent that are involved with ipsec development. So if you have really technical questions about setups or code or operating system issues, then you can always go there and ask us. There's a lot of information available on the internet. There are good articles available, so this won't be a problem.
Mention this book.
Oh yeah, and we have a book here. This is a good overview of ipsec.
It's actually it's actually about the only book currently available with a good overview of ipsec and how it works. There's actually, well, ipsec is not new, but it's hasn't really been publicly used a whole lot until about a year ago. So there's very few good books on it, but this is one of them.
Okay, we are still working on ipsec configuration for Hull. I will add one URL here, because if you look at we are very flexible here. If you look at the campsite website, like tomorrow, or sorry, this afternoon, we will probably have more information about the setup that we have built here. The setup that we are building here allows you to use ipsec to the main router, or at least the same network segment on which the main router is connected, so that you can have a secure connection on the whole network. Nobody can see what you're doing, nobody can tamper with your traffic.
Except for the ipsec team.
Except for the ipsec team, but you will have to trust us. Yeah, that's basically it. Yeah.
Just two things about the configuration. We have a script running. There will be a CGI on that web server where you can get a configuration. If you are using OpenBSD, that configuration for the client is generated, so you can just download or copy and paste it. If there's anyone here who wants to volunteer for the freeze-one configuration, so we can change the script to that. Ah, okay. And one last thing, if you want to use ipsec in here to hide your rogue activity, always remember, we have all passwords, we can decrypt anything, and we will look at you.
Any question? Ask.
Yeah, any questions? If you are going very into detail, just contact us in the FHQ or anywhere else, just intercept us. So any details can be talked about then.
Okay, I think this is the end of our short session.